video 11, we talk about passive design. So why do architects include all these extra costs we've outlined in the previous videos 1 to 10? Are we high or just continually drunk? After all, houses are required to have star ratings, right? Yes, they are, but that's not the answer, is it? Who really wants to live in an esky or a chili bin for my New Zealander friends from across the ditch? What we really want is thermal comfort instead of having to rely on the air conditioning. That's why we see architects come up with unusual step plans for more light and airflow, higher walls for more light and airflow, more glass for more light, more and larger openings for more light and airflow, higher ceilings for more light and airflow. These are all the ways to bring the outside and the view in and extend the inside spaces outside. The house shown here is the best and most energy efficient house I've ever designed, and was extremely confident that it would rate about 9 stars. Why did I think so? I carried out extensive sun studies and perfectly orientated the building and overhangs to totally control the sun. It has some double glazing, it has low E glass, it has roof, wall and ceiling insulation, and it has floor heating. Finally, it has reverse block veneer. Reverse block veneer? What did you say? Yes, we use block internally rather than externally for its thermal mass and aesthetics. Block actually absorbs heat and contributes to the coolth of the house. You've all evidenced this effect in caves. In addition, we have used honed and polished blocks for the looks as well. Ironically, they will give us warmth often expected in colder climate houses. The thermal mass of the blockwork will also absorb the heat from the fireplace and re-radiate it back into the room at night time. I believe this is a real passive house in that it does not require any additional heating or cooling. The passive house movement is distinctly different in that it works on the principles of totally sealing the building and mechanically heating and cooling all year round. I suggest this is active as opposed to passive. There are certainly places where it is an appropriate design solution in Australia, but not in areas where our climate is generally benign. In summary, I believed I ticked all the energy boxes. So you, like me, would be surprised to hear that it actually modelled at 5.5 stars as national building regulations are designed, assuming all houses are air-conditioned, esky homes with small windows. It's actually the amount of glazing that killed me, even though I used low E glass and some double glazing. You see, glass is either designed to keep the heat out or to keep the heat in. I did a week's research on this to find the right glass. The design uses shade control to keep sun off the glass in summer. The problem is, it's hard to find glass designed to let the heat in and trap it, which is what you want in winter. As it turns out, the bedroom's rated 9 stars and the living room 7 stars. The breeze solarium, which I'll discuss later, arguably the best climatic design feature, rated 2.5 stars. Under the standard deemed to supply climate model, the internal breeze solarium would actually rate higher if it was permanently open on both sides. That is great when it's 40 degrees outside, which it gets on this site. Not so great when it snows, like it has on this site. Sure, we could have received a more accurate energy rating if we paid much more to have the building modelled under a non-standard criteria. But why should my client have to pay extra to prove that design is better than the actual software? We didn't, and empirical data has shown that 10 degrees less temperature range than outside daily, even after 4 consecutive days of 36 degrees. The Bureau of Meteorology red figures show the 14 degrees variation outside. Inside in the green you can see that we've achieved 5 degrees variation or 9 degrees less. In winter, when it was -3 outside, it was 14 inside, 17 degrees warmer, with no heating. The next video, video 12, discusses the value of good design.